Today I'll talk about multi-criteria decision analysis, MCDA, or decision making, MCDM, and how we can use this tool in order to define what's the best process in order to reprocess the tailings at a mine in Spain. This is for a strontium mine. So most of this was already covered by Noemi. I'll go quickly over it. But what is strontium? It's a critical raw material. It was defined as such by the European Union in 2020, and it was confirmed again in 2023. We expect it's going to happen the same this year. And this is mainly because it has a medium supply risk. This is mainly because all the strontium of the European Union is produced in Spain. And it has a growing economic importance. There's about 1 billion tons of reserves of strontium. That is guessed, actually, because even the USGS says that they don't have a real number to put out. But we do know that the major reserves are in China, Spain, and Iran. And as I said, 99.3% of all the strontium that the European Union requires is produced by Spain. Now a little bit about the market dynamics. So the production of strontium grew up from the 70s until 2005 in a very exponential way, as you can see here. The main mineral that is mined is celestine, you can see here. But what happened in 2005? Why did it crash? And you can see actually it starts falling the production again. Well, the main use of strontium up to that date was in cathodic ray tube televisions, so the very old square televisions. And it was using the glass, so it would protect the viewers from the harmful radiation from the cathodic tube. And everything changed in 2005 when Sony launched the LCD television. So this shows how technology can actually generate this crash in certain markets. But you can see now that there is a grow again in the production. It's actually reached, has surpassed the peak that we had in 2005. So what's going on with strontium? There's a new market for strontium mainly associated to magnet technology. And this is pushing the boundary basically on how we can use electrification without depending on rare earth elements. So it's technology that could either replace or at least live with rare elements in order to have low rare element magnets technologies. And other emerging technologies are in nanotechnology and smart materials. So this is pushing this new revamp for strontium. All of this was summarized in the first review of strontium that we published as a group for Rotate last year. And in that literature review, we analyzed the market dynamics, the different applications, but we found that the main gap in the literature and the most concerning criticality around all this is on sustainability. There's 0% recycling of strontium in the European Union, and there's clearly a gap on how much we know about the sustainability of the process. So in academia, when we see gaps, we see opportunities. So last year, with Chalmers and Canteras, we published the first paper on assessing the sustainability of reprocessing the tailings of a Celestine mine in Spain, in Canteras Industriales. And that project basically considered 4 different ways of operating their current mine, their current design with the dense media separation that Noemi was presenting earlier on. Something interesting of that process is, well, we had the design, right? And we did simulation of how the different flow sheets could operate. And with those simulations, we did life cycle assessment to understand their environmental impact. And we have 4 scenarios, 4 ways of operating. And we can see that scenario 4 is the one that produces the highest revenue, so good news. Also is the one that produces less tailings, so even best news. But it is the one that produces most of CO2, almost double the CO2 of the other alternatives. And this is when LCA stops being useful. LCA is very good at quantifying impact, but then how do you make a decision of, okay, I'm gonna live with more CO2 and have less tailings, or the other way around? So what impact is more important for that particular mine, for that particular operation? On the other hand, in that review I was telling you earlier on, we found that there's different ways of concentrating celestine. So as Noemi mentioned, they used to do concentration by size, and now they're using dense media separation, which is a gravity separation process. But you could be using frost flotation, shear flocculation, leaching, and others. So how do we decide what is the best process for that particular operation? This is where multi-criteria decision-making, last time I say it, MCDM, enters into the game. It's a tool, it's a mathematical tool that allows you to make transparent and unbiased decisions. And it's helped quantify the subjective opinions of these different criteria. So I want to be sustainable, but also make money, but also don't bother the communities. How do these things weigh each other? And how can we transform this problem, this multi-objective problem, into an optimization problem? So the way that MCDM works is mainly by considering the opinions, and therefore through questionnaires, for decision makers and experts in the different fields. So we usually separate things into criteria, for example, environmental criteria, economic criteria, and alternatives that say operate through flotation or operate through dense media separation. And then we consider all the uncertainty on the responses of the multiple decision makers. And then we do a Monte Carlo simulation based on their replies using a beta distribution in order to consider the whole space that is being defined by this sample. And with that, we can assess the weight of these different criteria with a stochastic value for it as well. So that may sound a bit esoteric, so I'm going to give you an example. Let's do the case study of Canteras Industriales again. This is the current flow sheet that they're operating, which, as I said, operates by a concentration by size, generating these two products here. And then those tailings, this laser is not very good on the screen, sorry. Those tailings then go into a whole flow sheet of dense media separation to produce more concentrate. But we have more alternatives. As I said, we have dense media separation, we have frost flotation, and as Noemi mentioned in her presentation, they also consider spirals and shaking tables. And criteria, there could be many, but we decided to settle on environmental impact, technical feasibility, social impact, and economic outcome. So how do we measure each one of those? Is with all the tools that you have been developing in Rotate platform. So for example, for environmental impact, we can do a plant simulation, as we did in the previous paper, do LCA over that simulation, and also use questionnaires to weigh those different categories. In the case of technical feasibility, we can use expert opinions and also the simulations in order to know how much we're concentrating and how much material we're moving, etc. Social impact, so far we've only worked with questionnaires for stakeholders and for decision makers in the community, in the plant. And for economic outcome, we also use the simulations to understand how much material we're producing. So I don't have time to go for all the alternatives, so I'm going to show a second alternative, which is frost flotation. So you see that at the left, the plant is the same. We are operating with the same circuit, but now the tailings, instead of going to a dense media separation, are going to a complex flotation circuit. This circuit, we had to design it completely, but it's based on the design of a plant nearby Canteras Industriales. So we know that this sort of circuit could work for this mineral. And as you can see, I don't want you to read all this, but I want you to see how many assumptions and variables we need to consider every time we do one of these simulations. So in this case, we need to understand how the flotation process is going to work, what are the assumptions, what are the reagents, because that matters in order to do the LCA analysis. We did that using PlantSmith, and we did the LCA analysis. And now we can quantify the impact on different categories. We know, for example, now that that flotation plant would require about 5 times more water than the dense media separation. Here is everything relative to dense media separation, okay? So we know that we need 5 times more water, 3 times more energy coming from fossil fuels, and about generating double the CO2 emissions. So it's relatively clear that flotation has a higher environmental impact than dense media separation. But how much? How much do we care about all these different impacts for that particular mine? So this is where MCDM enters. We did this kind of questionnaires to different decision makers in the mine. For example, how important is for canteras to minimize the greenhouse gas emissions for its power, diesel, and reagent consumption, where you can give points from 2 to 8. And we use this kind of questionnaire with questions that allow us to anchor those rankings that you're generating. So if you could have one of environmental impact across all operations, which one would you choose? Or which 2 environmental impacts are the least important for your operation? That kind of question allows us to give some weight to these different LCA outputs. And with that, we generated this kind of weighing system for the different criteria in the LCA output. So we see, for example, that for canteras, after doing questionnaires to the decision makers and also to important stakeholders, we see that the main aspects are the acidification potential. So how much do we impact the soil and therefore the potential for plantations nearby? The eutrophication potential, so basically, are we contaminating the fresh water? And the ozone potential, basically, are we releasing too much dust into the environment? Whilst, on the other hand, the least important for them was ADB, which I forgot now. I'll come back to what it was ADB. The depletion of fossil fuels. So that was the least important for them in this case. And with this kind of weights, we can now say with numbers that the desirability of using dense media separation is about twice using flotation from an environmental perspective. Okay, so now we have numbers on how much is the impact from an environmental point of view. Now, if we combine this with technical, for example, how much more we're producing, with social, are we employing more people, for example, and then we weight those categories as well with the same method, then we can make a framework to make the decision of which is the best process for this particular mine. Thank you very much.